Welcome to the OneWebSQL demonstration. OneWebSQL helps you write and change database code in a simple and reliable way. This presentation will help you learn the basic features and typical workflow. Here is a very simple web application. It is an online bookshop that displays information about available books and their authors. It consists of a single servlet with a single data source. All application data is stored in the PostgreSQL database, made up of 4 tables. Let's start with the author table contents. There are 2 columns for each record, identifier and author's name. Right now, the table contains only 2 records. The application is built using Maven 2. To use OneWebSQL, we have to specify a runtime library dependency and set up code generation plugins. The first plugin translates a graphical database model into an XML description. The second one generates a Java source code from the XML description. The application servlet generates then an HTML page that displays a list of book authors. These lines set up a response content type and define a page header. The servlet retrieves all author records from the database and displays them as an HTML table. To fetch records, we need to create a data access object. Its constructor takes 2 parameters, JDBC data source and data adapter object. The database adapter allows OneWebSQL to use a database-specific SQL dialect. The code uses the getAuthorList method from the author DAO class to retrieve all rows from the author table. This method returns a simple Java bean for each row retrieved from the database. Each author bean represents a single author record. Each field in an object corresponds to the column in a row. This code iterates over all beans and prints an HTML table row for every one of them. Finally, the servlet generates an HTML footer and closes the output writer. Let's see what our application looks like in a web browser. As you can see, the page displays a list of authors. Let's add a new author record. On browser refresh, the list includes a new record. Now let's add a list of books to our application. To save us some typing, we copy the code that displays the list of authors and change it so that it displays the list of books. Copy and paste. Let's change the comment and the table header. We delete the old code and write the book printing code from scratch. First, we create a new book DAO instance. Each DAO has its own interface, which is used by the application to access each DAO implementation. We pass both data source and database adapter to the constructor. Then we fetch and iterate over all book records in the database. Every record is represented by the book bean. The getBookList method returns all records from the book table. For each book record, we write 2 HTML table columns. The first column displays the book identifier. To get the book identifier, we use the getBookID method. The second column displays the book title. To get the book title, we use the getTitle method. Let's see the changes to our application. The server's view indicates that we have to restart the Tomcat server to synchronize all the changes. We switch over to our browser and refresh the page. Now the application displays the table with 2 book records. Let's add another book to our database. The third book will be The Art of Computer Programming by Donald Knuth. One more browser refresh, and our application displays 1 more book. But the second column header is wrong, so let's fix it. And yet another page refresh. The column header is now fixed. Now we will demonstrate how database changes affect the Java code. For every database table, OneWebSQL generates three kinds of objects: a data access object interface, a data access object implementation, and a Java bean that represents a single database record. Let's look at the objects generated for the book table in our database. The book class that represents table records, the book table DAO interface, and its implementation. Every interface provides methods for common operations on the corresponding database table. But how does OneWebSQL know what objects to generate? It retrieves this information from the Sybase Power Designer database model. All we have to do is point the code generation plugin to the model file. Here is a model file in the project directory. Let's see the Power Designer model. There are 4 tables in the database. We already know the author table and the book table. At the start of the project, we generate a database creation script. Let's see what the SQL script looks like. The script contains generated create table statements. Later in the project, we change the database. Before doing that, we make a copy of the database model, which will be needed later to generate a database upgrade script. We save the copy under the Bookshop Before Author refactoring name. Keeping the author's full name in a single column is inconvenient, so let's split it into first name and last name. First, we rename the existing column to first name. Then we add the last name column. The new column type is character varying with a length of 100. We also make it a mandatory column. Now the table has 2 columns instead of 1. To modify the database, we need a migration script. Power Designer will generate it for us. In the script generation dialog, we have to specify the archived model that we saved earlier. We also set a new name for the script. This window displays changes that we've made to the database. The original column was renamed to first name, and a new column, last name, was added. This warning means that Power Designer needs our help with the migration script. Let's open the script and see what it looks like. All cases that need to be fixed are marked with the warning comment. We have to define value for the new table column in the place of a question mark. The business rule says that we split the author's name into first and last name on the first space character. We extract the first name from the name column with the substring function. In a similar way, we extract the last name from the previous column value. Let's run the corrected version of the script. The database processed the script without errors. We double-check that the database changed as intended. We press the button with circled arrows to refresh the database view. Quick check reveals that the author table contains now 3 columns. A single name was replaced by the first name and the last name column. Let's refresh the Eclipse project. The new SQL scripts appear in the Project Explorer view. To generate a new Java code from the modified Power Designer model, we run Maven. The console view displays messages printed by the code generation plugin. The new code is generated. To see the changes, we refresh the Eclipse again. The Problems view shows a new error, so we jump to the offending code. What happened is that the author class no longer contains the getName method. The method is missing because the name column is no longer in the author table. Now the table has 2 new columns, first name and last name. So instead of the getName, OneWebSQL generated the getFirstName and getLastName methods, one for each column. To fix the code, we replace the getName invocation with getFirstName. We also changed the label to display the new column name. Now we add the code that prints author's last name. Let's copy the code that displays author's first name. Finally, we call the getLastName method to display author's last name. The error disappears when we save the code. To see the changes, we reload the page in the browser. It looks like the column header is missing. Let's add the last name header. Now there are two columns on the screen: author's first name and author's last name. Right now our application displays two sets of data, authors and books. Because it is not very user-friendly, let's change the application so that it displays books and authors as a single list. The data we need is stored in the author and book tables. The database uses the book-author table to store relationship between books and authors. We have to bind or join these tables to fetch authors and books in a single SQL request. Let's create a database view that makes that join. First, we have to save a copy of our current model in order to be able to generate an upgrade script later. We set the name of the copy to Bookshop before new view. We click the view icon to define a new view. We set the name of the view to Book with Author. Let's write the view definition. The view returns 4 columns: book identifier, book title, author's first name, author's last name. We joined the book table with the book author table by the book ID column, and with the author table by the author ID column. Now the only thing left is to define column types. And now the complete view is ready. Let's generate a database upgrade script. We set the script name to Bookshop after new view. We select the previously saved copy of our model. Here we can see the database changes made by the upgrade script. The Book with Author view is our brand new database object. We check the generated script. Here is the create view statement generated by the Power Designer. Let's run the script against our database. The script runs with no errors. We refresh the application tree to see the database changes. Our newly created view appears in the Views node. Quick check reveals that it returns valid data. Maven generates a new Java code from our updated Power Designer model. The console view displays messages printed by the OneWebSQL code generator. Maven build completed successfully. To see the changes, we need to refresh the Eclipse package view. First, we remove the code that displays the authors. Then, we rewrite the rest to display our books with authors as a single list. The list needs 2 more columns, one with each author's first name and the other with his last. Let's rewrite this section, this time using the newly created Book with Author view. Using the same steps, we first create a Book with Author DAO instance and provide it with the data source and the database adapter. Next, we fetch all rows from the database. The Book with Author class represents rows from our view. The getBookWithAuthorList method returns all rows from the view. Let's format the code to make it more readable. We will use an additional DAO feature and sort all our records by the title column. To sort the rows, we pass the view column as a parameter to the getBookWithAuthorList method. OneWebSQL generates column constants for each data access object. Now it's a simple matter of writing HTML table rows using the retrieved record. The first HTML column contains a book identifier. The second column contains a book type. As with all database tables, OneWebSQL generates an accessor method for every column of the view. The third column contains each author's first name, and the fourth column contains his last. Let's restart the Tomcat. It's time to check the application in the browser. Our application works as intended. However, the art of computer programming is not being displayed. That's because there is no corresponding joined record in the book author table, so we need to add it. The Donald Knuth record has an identifier of 3, and the art of computer programming record has an identifier of 3 as well. And so a new row appears. The records are sorted by title.